Hello, everybody. Who has been here yesterday for the workshop day? Somebody? A few people. Okay, awesome. So I made it here at like 1 a.m. in the morning. I have 5 hours of sleep, so I need you all to be very energetic for this keynote so I can keep going. Now, thank you for having me. Thank you for the organizers. It's really exciting to be here. For this keynote, Back to the Future in the space of cloud-native technology. Now, you might have heard this phrase before. There's an old saying that those who cannot remember the past are being condemned to repeat it. Usually we talk about this regarding history, that we have to think about all the things that we did well in the past so we don't reinvent the wheel. And we also have to think about all the things that we did bad so we don't repeat all those negative events that we've already done. Now, this saying is across different languages. I know it from German, I know it in English. And that's something I want to talk to you about today in regards to cloud-native security. Now, what happened in the past 5 years? Well, in the past 5 years, we take our DeLorean back 5 years, about 5 years ago. Now, this theme is based on our Aqua Security theme that we have currently going on at different booths. Basically, what would we have done differently throughout the past 5 years if we would have the same knowledge that we have today? That's kind of the idea. So what happened 5 years ago? This is me 5 years ago. At my first role as developer advocate, right before my first travel actually, from Berlin to London. I was working at a company called Near Protocol at the time, not in the cloud native space, but in the blockchain cryptocurrency space for open source projects. Also 5 years ago, we lost 2 very special people, special in different ways. Stephen Hawking died on the 14th of March, and Avicii died on the 20th of April. If you are into the royal family, 2 things that happened there. William and Kate had their 3rd child, and it was before all of the Meghan Markle and Prince Harry drama when they got married. But this is not why we're here, to talk about the news. No, 5 years ago, a little bit more about myself. I was working in the crypto space, like I just mentioned. And then in 2020, I joined a company called CodeFresh, which is a CI/CD platform working with GitOps, cloud-native tools there. Then in 2021, I worked for a company called Civo as SRE. And in 2022, I joined Aqua Security as their open source developer advocate. Now, along the way, I became a CNCF Ambassador of the Year in 2021. However, I'm not a CNCF Ambassador at the moment. I'm an Open UK Ambassador, which is an organization in the UK to promote open software, open hardware, and like the policies around open source. And I also just became a Grafana Labs Ambassador. So that's it about me. But I want to talk to you about DevSecOps and what we can learn from events throughout the past years in the security space. Now, DevSecOps, just a quick recap, is basically stands for Development, Security, and Operations. And it's basically the approach to have shared responsibility across your DevOps lifecycle regarding security. So if you talk about DevOps and combining operations with development practices, we want to, in the DevSecOps space, we want to talk about how can we keep all of our tooling secure or enhance the security of our tooling along the way as well. Now, things that we can all agree on that can make our DevOps lifecycle more secure in general are the following. Things that we kind of know that we could implement it, or if we follow them, they can make our DevOps lifecycle more secure, is if we fix bugs early. So if we find a bug, we address it early and not let it evolve, have children, populate across our different stack. Then shared ownership is a big thing. If we enhance shared ownership, let people take responsibility for their different resources, and also address security issues as they found that can reduce the security risk across our stack, across our organization. Automation is another big thing. Usually when we talk in a cloud-native ecosystem about automation, we talk about observability. How can we automate our deployment processes? How can we get further insights into our deployment processes? GitOps, for example, is there to give us insights into who deployed what, when was it deployed, where was it deployed, and how. Those are all insights regarding observability, and we automate it through GitOps best practices and tooling such as Argo CD. Now, in the security space, we don't talk about automation as much, or it's kind of perceived as a separate practice a lot of times. Now, if we do manual security scanning, for example, and manually introduce other security tooling, then we have decoupled processes. So if we talk about security as a holistic perspective across our DevOps lifecycle, we also have to talk about automation. And we can all agree on that if we generally use the latest tech, upgrade our different libraries that we're using to not have CVEs over prolonged periods of time, that can reduce the risk that we expose our stack to. Now, these are all of the things that we kind of can agree on. We know that these are things that we can do. Like, you know that certain things are just best practices, but the reality is often very different. So where do things generally go wrong? That's what I want to look at in more detail in this keynote. Where did things go wrong, and where do things still go wrong in many organizations? So usually in the DevSecOps space and security space, there's lots of finger pointing going on, especially if you have a separate security team who has their own objectives that they need to reach. You have the DevOps team, they have their own objectives. In lots of companies, the DevOps team is still perceived as like a cost center. Same with security. It's like they are the people who intervene usually in the normal development process, which we don't want to have this kind of decoupled situation going on. Now, I found this tweet by Malavika really, really on point, saying that reality is that the business will push to get the update into prod, and InfoSec will pray that the vulnerability doesn't get exploited. It's why defense and dev is so critical for containers. So you can ship your code, you can ship your application, even with security issues. Now, if customers can't reach your application, can't reach your stack, then it can't be shipped. So that's the difference kind of between observability and security monitoring. Now, I want to learn a bit more about yourself, and this is the part where you want to get involved. These are some of the stats that I took from a survey by Red Hat. They interviewed around 600 people in this space in their 2023 DevSecOps survey. So I want to get an idea of who are you in this room and what does your organization do? So do you think your organization does enough related to cloud-native security? Hands up. Do you think your organization does enough regarding security? Okay, a few hands going up, especially right there. These are the security folks you want to talk to, okay? So everybody who didn't put their hands up, your organization goes above and beyond regarding security, right? That's, okay. Okay, so generally they found that 38% of respondents believe security investment in containerized operations is inadequate, a 7% increase from 2022. Now you could argue that maybe there have been more people taking the survey. Cloud-native adoption is increasing, so that's why there is an increase. But generally, we can, I guess, all agree that there's always something else we can do regarding security practices. Second question, have you ever been prevented to advance a tool based on security concerns? Have you ever been prevented to implement a new tool based on security concerns? Did anybody in your business ever say, oh, you shouldn't implement it, or we can't advance with this stack because of... Some hands went up, okay. So about 67% of respondents have had a slowdown in cloud-native adoption due to security concerns. Now, as we talk here as a space in the tech industry, in the cloud computing space, about advancing new tools, you will hear today a lot about different new shiny technologies. A lot of times you can't actually implement them at the pace that you might as SREs, as infrastructure engineers, as platform engineers would like to implement them. Because usually when we build new tools, the UX of those tools is advancing way faster than what security best practices and security practice can catch up to. Now, I want to talk to you about different attacks that we've seen in the past years that we can learn from in various ways, just example attacks as well. Now, I've took this graphic from a post by Acra Security. I've added supply chain attacks. That should be attach, not attach. And we will look in detail at these different attacks. Now, some of them are kind of overlapping, and one attack leads to another attack. And we're going to start off with supply chain attacks. Who has heard of supply chain attacks? Who knows what a supply chain attack is? Okay, lots of hands going up. It's kind of the thing that security in the cloud-native space likes to talk about a lot. We talk about supply chain attacks a lot because most of our tools as well, they address supply chain issues, security of our software supply chain. So last question for you, for now. Who here has discovered a security issue in their software supply chain in the past 12 months? Didn't have to be exploited. You just identified something that wasn't to security standards in your software supply chain. Okay, more hands going up. Lots of hands. Good. Those who didn't put their hands up, probably you just don't know yet that there is an issue. There is always something that we can advance, right? Especially whether that's a misconfiguration, CVEs that we could fix. There's always something we can improve in our software supply chain. So more than half of the respondents actually have experienced a software supply chain issue related to cloud native and containerized development in the past 12 months. That's a lot, and that's why we talk about it. Now, generally, software supply chain relates to everything that is within your code, that touches your code, that manages your code. That also relates to the people, the culture, anything that's related, your processes, your standards, anything that's related to you shipping software, whether that's like your launch plan of new features, something. Anything that touches it anyway is part of your software supply chain. Now, we're going to look at different supply chain attacks now. Who has heard of the CodeCaf issue in 2021? Okay, anybody here working at CodeCaf? Okay, awesome. So CodeCaf is a code coverage tool scanner. And fun fact is, in 2022, when I was working at CodeFresh, I actually wrote a blog post on how you can integrate their malicious installation option into your CI pipeline. And at the point, my manager at the time actually explained me why it's not the most secure way of installing CodeCaf in your CI pipeline. And that's actually what happened. So basically on the 31st of January, about a little bit more of a month later than when I published this blog post, an incident happened, an exploit took place, and it was discovered on the 1st of April 2021 by CodeCaf. So basically hundreds of clients were impacted by the issue, and the attackers exploited a mistake in how CodeCaf built Docker images. They used this to modify a script that allowed them to send the environment variables from the CI of CodeCaf customers to a remote server. So you have to think, who's using CI pipelines on a regular basis? Okay, yeah, everybody. So basically, CodeCaf is installed like many other tools. It runs as a container, but you basically, as far as I remember, you pulled the image in through like their script that you like accessed. Now the thing is, usually there's like a signature kind of on their container image, on their artifacts that you're using that states this is built by CodeCaf. Now one of their customers did some changes, did some updates to their pipeline and realized that was not the same signature anymore. So it's probably not CodeCaf providing me that artifact. So they contacted CodeCaf. That's how they realized that there was an issue. Now I want to point out here that CodeCaf responded very quickly. They contacted customers in a timely manner. They rotated credentials. They even pulled in a third-party cyber forensic firm to conduct an audit. So if you compare different security issues over the past years, companies responded in very different ways to security issues. And CodeCaf, I think, is one of them that respond in a very proactive manner. Now, next week, SolarWinds. Who has heard of SolarWinds? Okay, yeah, it was also a very popular or like very well-known, issue. So basically, SolarWinds has several different, lots of different software that you can basically use for different purposes. They're like a monitoring company, as far as I know, and they have a software called Orion. Now, Orion, similar to other software that you use, sometimes it needs updates, right? So as part of like a regular update to the Orion software, the hacker slipped in malicious code into software that they used it as the basis of the attack. Now, they didn't just like get access to the supply chain of SolarWinds and then modified the code. They first tested it. Once they got access, like they managed to get malicious code into the packages that were then like distributed to customers. They first tried it out, like, does it actually work? And then they took their time to see if actually they were able to distribute their malicious code across customers. That worked. And then they launched their attack next. So there's basically the first thing is that SolarWinds didn't realize that their code was already modified in a non-malicious way. Next thing, they implemented the malicious code and it mimicked the Orion software communication protocol so they could hide in plain sight. Basically, what they did is, or what software supply chain attacks usually try to do is, right before your code gets converted into executable code from human readable to machine readable code, that's when attackers want to modify it, want to get their own their own code in. Now, it got ultimately downloaded by around 18,000 customers between March and June of 2020. But that doesn't necessarily mean that they got that 18,000 customers got exposed to the issue. Ultimately, it required two conditions for this code then to actually work. First, you had to download it, then you had to deploy it, and then the servers also had to be connected to the internet. It wasn't possible if they were in an air-gapped environment. So generally, supply chain attacks are more sophisticated of that sorts. The thing is also that SolarWinds missed several different, like along the way, they missed several, I guess, signals of sorts. So once the attack got launched and so on, a security company called Palo Alto Networks discovered there is a malicious backdoor and traced it back actually with SolarWinds. So they worked together with SolarWinds to identify the issue. They couldn't find it. And that was like once the attack was launched. Now it took for a company called FireEye to realize that one of their employees had actually 2 phone numbers registered instead of 1. And based on that, they identified that there was an intruder in their system. Now, usually, I don't know about you and your company, if I see one of my coworkers having registered 2 phone numbers, I don't necessarily think anything bad about that. So it's kind of like, from my perspective, seems a lot by coincidence that this issue was actually then discovered. So what the team at FireEye discovered was that over the course of several weeks, not only was there an intruder in the network, but someone had stolen the arsenal of hacking tools FireEye uses to test the security of its own client networks. FireEye called the FBI, put together a detailed report, and once it had determined the Orion software was the source of the problem, it called SolarWinds. So this was ultimately how it then got resolved, or known to SolarWinds and then resolved. Now, separate to this, SolarWinds also, like different people along the way, reported different issues. Now, generally, SolarWinds was a good target because of the way they displayed information about their customers, their users, on their website. So they were basically described as a shopping list for attackers, which is obviously you don't want to put that information out there, right? You don't want to detail who of your clients uses which part of your software. That's one thing. The other thing is that they had other security issues as well, as it seems. So if an attacker sees that a company has other security issues, then they might be an easier target for additional attacks. So that's SolarWinds. Now let's move on to account hijacking. Who knows what account hijacking is? Okay, everybody? Cool. Most people. Account hijacking is a type of cyber attack during which an attacker takes control of the victim's account associated with a computer device or online service. Now, that could be like through a phishing attack, for a social engineering attack, right? But basically, it takes over some control of somebody else's computer platform. Who has heard of MGM? Okay, few people. It was just in the news. That's why I put it there, because I thought it was really representative of what's going on. Now, MGM is a hotel resort giant. They have their worth of over 14 billion, and they operate over 30 hotels and gaming venues. Now, think about gaming venues as in like gambling versus like video games. Now, what happened there is that because they have so much money, they got attacked through a social engineering account hijacking attack. Basically, the attackers, they found an employee of interest on LinkedIn, and then they called the help desk to pretend that they are that employee and they needed their accounts to be reset. Now, you probably think I mean, who does that? Or like, how easy should that be? But basically, most people with machine learning solutions can pretend to like distort their voice to pretend they are somebody else. If you're very authoritative and there's somebody and you're intimidating that person who's on the other end of the line, it can happen quite easily that somebody then gives you access to information even that they shouldn't give you access to. So their system was down for about 3 days, and it basically caused a disaster across their different branches, with rendering doors to the changed casinos and hotels unusable, slot machines and ATM machines were also inoperable, and elevators were out of order, and customers had to wait hours to check into rooms. So that's basically for hotel chain, that's a disaster, right? And a lot of times what happens is that hotel companies and similar are targeted more often because for them it's easier to pay the ransom than to actually than to have their systems not being usable for several days until the attack is resolved differently. Now, around the same time, another company called Caesars Entertainment, who has been to Las Vegas, heard of Caesar Palace? think that's part of the same group. Yeah, so they got also hacked, and they actually paid already half of the ransom by the time that I read the report. So the entire ransom that was requested was $30 million, and that's easier to pay again. Now, in the case of Caesar Palace, Caesar's Entertainment, they didn't want to comment on the issue, and that's something that seems to be like a pattern in tech companies versus non-tech companies, that non-tech, primarily companies, they respond to issues differently, let's say. Now, we've just talked about software supply chain like from the code perspective, as in like accessing different components, either through like accessing the code or actually exploiting other vulnerabilities. So ultimately, our software supply chain, the security of our software supply chain is only as good as the weakest link, and that might be also people, processes, or culture that we have. Now here, two other more simple security issues, they got presented by security researchers at Aqua at Black Hat Asia 2023, so that just happened. And they basically talked about how easy it is, for example, to become verified on the Visual Studio Code marketplace and then publish plugins. It's very straightforward. You don't have to have lots of information, credentials to actually get verified. And everyone is repo checking, where basically a lot of times when companies get acquired, they move their repositories from GitHub into another organization, and then eventually an attacker has the option to, if they don't keep their old name, to take over the old name, even if there's like a hyperlink to it. So these are like things that we can kind of keep an eye out, that we like smaller, I guess, they seem obvious to us, right? Like if you look at these issues, they seem obvious, and of course we would pay attention to where we download our resource that we're using, but a lot of times we might not pay direct attention. For example, this happened to me last week, that I was actually stuck in Berlin, and I was tweeting about being stuck because of EasyChat, and this account replied and asked me to send them their phone number. Now I went to their account, and I was about to message them, not with my phone number, but I was about to message them, and I found it weird, first of all, that they were following me, and second of all, that no, you are laughing, but it's like an EasyChat company wouldn't necessarily follow me. And then I also realized like that is like they hardly have any followers, but that's just like if you're overtired, if you've been awake for 15 hours, you might not necessarily think that's straight, right? And that can happen. Now, here's another, well, also like careless mistake, if you will, if you want to call it. So Viz just published a report as part of Viz research. They discovered a massive 38 terabyte data leak by Microsoft AI researchers, including 30,000+ internal Teams messages. And that was also because of inadequate authentication measures. Who has heard of that? We've seen that before. That also just happened, literally. Yeah. So last thing, or like next thing, CVs. How much were we with time? Don't know the time. How much time do I have left? I'm good? 15 minutes. Okay, awesome. So CVEs, this is what usually happens. You want to ship your new feature, and then your security team is like, wait a minute, they are high in critical issues. You shouldn't go ahead with that. Big shout out to Malavika for providing me with content for my keynote. So basically this happens in a lot of companies or different teams, that you might have, for example, security scanning of your container images, of your different artifacts to expose vulnerabilities as a separate step, and then it's stopping you to do your job, basically, to do what you want to do. Also, a lot of times we get overwhelmed with vulnerabilities with CVEs. If you have over like several hundred different vulnerabilities in your container image, who's gonna, like, you need to apply some filtering to know what to do with them. Now, we take a little bit further step back. Who has heard of Heartbleed? Everybody. I should choose some that people haven't heard of, right? That might be more interesting. Yeah, so Heartbleed, 2014. That was actually while I was still in school, so it was interesting for me to relearn about it. So the Heartbleed extension basically provides a way to test and keep alive secure communication links without the need to renegotiate the connection each time. Now in 2011, researcher at a university in Germany implemented Heartbeat into OpenSSL, and at the time when it was reviewed, they didn't find a bug in the implementation. So about 2 years later, Google security team privately reported to the Heartbleed vulnerability to the OpenSSL team. Now, that also happened on the 1st of April. I want to you to know that there's a theme here, that security issues are usually reported on the 1st of April. So, no, it's just 2 out of the ones somehow that I've chosen 1st of April. Anyway, so the defect spread with the OpenSSL version 1.0.1, and it was basically enabled by default, and that caused at the time about 17%, around 500,000 of the Internet Secure Web Service certified by trust authorities were believed to be vulnerable to the attack, allowing theft of server private keys, user sessions, cookies, and passwords. I'm reading that here, so you don't have to read it. Yeah, so it was a major thing. At the time, you basically told, don't use the internet at all if you want to stay secure, if you want to keep your data information secure. But I think it's just one example where basically a CVE that maybe people have seen, right? Afterwards as well, cause lots of disruption. Or CVEs also long-term, like if you keep them in your libraries, can become an issue. Now, next thing is misconfiguration. I like to show this data a lot of times. Who is using misconfiguration scanners for their configuration, for their Terraform? Okay. Who is defining Terraform modules using Terraform? OpenTofu. Now, how is it called now? Using that. Okay, so why you want to use a misconfiguration scanner? It basically just tells you how does your implementation differ from best practices. Now, you can choose to ignore it or to modify your configuration or implement exceptions so your organization can do what they think is believed to they should do. Now, this is taken from a 2021 database, which is lists lots of, there's a source I can share it with you later, lists lots of misconfigurations, and many of them could have been prevented, such as no password protection or any kind of security protecting the database was set up, public accessible database. It usually relates to storage S3 buckets in AWS. Yeah, those are things that could have been prevented, and generally, well, whether or not that information was exploited, the information was exposed over a long periods of time. Now, what are some common patterns to summarize across these different attacks? Lots of time an attack goes undetected. Anyway, so basically what happens is that we have security scanners, for example, implemented and that tell us what is wrong in our existing code or the code that we set up, the configuration that we set up, the container images we're using. So they tell us what's wrong. But what organizations don't test on a continuous basis is how good is your automation system in identifying also the people that you work with, how good are they identifying on a continuous basis if there's something wrong within the system. And that also relates again to the ownership model that I talked about at the beginning, that if you empower people to speak up, also if there's an intern who sees, hey, there's one employee registered with 2 phone numbers, that's strange, right? They should be taken seriously in those cases. That's basically one of the takeaways here. You're generally the last to know. Lots of times, depending on the company, they will identify there's an issue. They will be told privately by security researchers, hey, they found an issue within their stack. Then they have some time to fix it before it's actually released, before other people are made aware of it. So if an attacker finds out about the issue about the same time and is faster than when the fix can be deployed, that's an issue. So you as an end user are usually the last to know, and that's why you want to have processes in place to test your system on a continuous basis so you can identify if there's going something wrong. Now, generally security measures will fail sooner or later. That's why we set them up. Now, that's why we want to set them up thoroughly. And security issues are going to be persistent. So you will find similar security issues across different environments, for example, that you have to address separately. Now, let's look about some of the solutions of tomorrow. What can help you to identify security issues? There are lots of enterprise solutions in this space, lots of them. Here are just some of them listed that I came across so far. I'm sure there are lots more because it's a huge space. Then there are lots of open source solutions as well. Who has heard of these solutions before? Okay, few people. So Sixter basically allows you to do what I mentioned earlier that helped to identify several of the security issues. Basically, you are able to provide attestations of your different artifacts, saying that you are the one who built that artifact. For example, you can say through signing your container images, you are the ones who built that container image, who's the origin, so people can actually verify that you are the ones who built it, and if the signature differs, identify that there's an issue, maybe, potentially. Kyverno is something that you can set up policies within your Kubernetes cluster. Yeah, it's a cloud-native tool within the CNCF. Tracy is an open-source tool by Aqua Security that uses eBPF to monitor your running processes, your running stack within your, for example, Kubernetes cluster. You can also implement it, for example, in your GitHub Actions in your CI/CD pipeline to identify any malicious processes. Now, there are lots of different security scanners, so pick one. Choose your favorite. There's really one for all of your different types of scanning needs. And here's an example of me doing secret scanning. So I tend to use other people's repositories on GitHub to, for example, build examples or just use them to test my infrastructure and so on. Now here's me scanning a Go demo application that I came across, a web application, and they had a GitHub token in it. So this is one where you can use secret scanning before you use other people's resources, for example, and other misconfiguration scanning. Now, the last thing I want to highlight is culture. Who has heard of this quote before? Culture eats strategy for breakfast. No matter what tools you implement, they will fail if your people are not, for example, going to use those tools, right? If you have security tooling, security scanning in place, but they're completely separate to your other monitoring solutions, people will have to access different platforms, different UIs. They might not end up use them. So this is really an old quote that was like, I don't know, it's like 50 years old or something, but it's a common theme across the space. Well, thank you for listening. Thank you for having me here. This is my keynote. You can find my weekly DevOps newsletter at this link on my website, as well as any other resources. And I'm generally available on Twitter for as long as it's not a paid-for tool. Also, Aqua has like a booth in the other building, so come say hi, get some swag. Yeah, thank you.
Thank you so much, Anais.
Yeah.
I think we have a lot of time for Q&A, so do people have any questions? I have a cube to throw your way.
Comments, questions, thoughts? No. Come on.
Just raise your hand.
Need more coffee.
Yes.
Yeah.
Just talk into the black part.
Yep. I was wondering, with how many different stages of security scanning and security tools there are, what do you think is the best way to present it to developers, especially if you don't want to constantly break their CI pipelines and say, okay, a new vulnerability here, now you can try and fix your Docker image, good luck, and stuff like that. How do you think it's the best way to present the vulnerabilities to developers and actually motivate them to fix it?
I think so. I mean, I talk as part of so for those, just recap, Aqua Security has also a really popular open source tool, open source security scanner called Trivy that I didn't mention in this presentation, but basically Trivy, as you could see here, does lots of different security scanning, and Trivy can be configured in lots of different ways to ignore specific vulnerabilities, specific misconfiguration issues. And a lot of time is really spent up in setting up Trivy, right? And I think that's something that has to be done by a certain group, like in a dedicated time frame first. So your engineers are not the ones who struggle to understand the information that they are presented with, right? So you should, I think, to get started, to introduce engineers into security scanning, for example, into container image scanning, you should introduce clear processes, runbooks. What should happen when your container image has, for example, critical vulnerabilities, right? Start with the critical issues, and clearly define what has to be done when. And then something I mentioned the other week, I mean, that's kind of something that I hear some companies do, right? Like working with them while using Trivy, that you basically implement. So basically, everybody has kind of their own responsibilities. Like for their stack is responsible, for example, for their container images that they're using. The processes are clearly defined, and then you have maybe like monthly check-ins and so on, of like how do their container images compare with other people's container images. Now, right, and then kind of compare of like, yes, like somebody might then, like it's their choice ultimately to implement the runbooks, and like there are the processes they are asked to complete regarding security practices, and then you can kind of see, okay, why hasn't it happened? And that's not to shift, like to put blame on anybody, but to see what's not working at the moment, right? If you have these checkup points, and then also be able to compare data, because something that's working for one engineer might not be working for the other one, right? So for example, somebody might prefer using more manual, like scanning, for example, through VS Code plugins. Again, Trivi has a VS Code plugin, and they can then do the scanning right there, versus other people might like to see, once they have kind of completed their build cycle in the CI/CD pipeline, the issues, right, later on. So I guess there are different approaches, and you have to identify like what works best for your engineers, but also, again, the responsibility, the ownership model, like if you not assign ownership of who's responsible for which resources and for how long, or for example, are they responsible for it, then people are not going to look at it necessarily, because again, you don't need to take care of CVEs for people to access your application and be happy with the way it's working, right? I don't know if that's helpful.
Thank you.
Let me know what worked for you.
I think everybody struggles a bit with us actually fixing them.
Yeah. I don't consider myself as like a security researcher or a security professional in that sense, right? So as much as you can minimize the noise, like the toil that you also receive from your security tools, that's the first approach, I would say.